Lesson, this is on factors and multiples. We're going to review this whole unit here. We'll start with factors and we will continue with multiples and then greatest common factors and lowest common multiples. We'll also review prime factorization. So just a quick reminder, factors are the numbers that basically go into a number. So for example, if we were looking at the number 18, what would all the factors of 18 be? They are the numbers that multiply to give you 18. So 1 and 18, 3 and 6. I'm just going to write them in order here. 2 and 9, and 3 and 6. All right, so 1 times 18 gives me 18. 2 times 9 gives me 18, and 3 and 6 gives me 18. So these are all the factors of 18. All right, and you can see that they're limited. There's a limited number of factors. Next is when we looked at multiples. So multiples, these were the way students remember this is when we talk about multiples, it's like the multiplication tables of 18. So if we were looking at the multiples of 18, 18 times 1, that would be your first multiple, 18. And then we would have 18 times 2, which is 36. And 18 times 3, 54. 18 times 4, which is 72, and so on. It will continue, right? So the one difference you'll see between factors and multiples, or factors, there's a limited number of factors. Multiples will just continue indefinitely. All right, after talking about factors and multiples, we started looking at what is a prime number and what is a composite number. So quickly to review that, prime numbers a prime number is a number that has only two factors, the number 1 and the number itself. That's how you know it's a prime number. So only two factors. The number 1 and the number itself. All right, so some examples of prime numbers included the number 2, 3, 5, 7, and so on. All right, so these numbers, they all just have two factors, the number 1 and the number itself. So 1 times 2, 1 times 3, 1 times 5, 1 times 7. All right, so that is how we defined a prime number. And then we defined a composite number. I'm just going to get to the page here. A composite number has more than two factors. All right, has more than two factors. All right, so that would be like the number 4, the number 6, the number 8, the number 9, and so on. All right, they have more than two factors. 1 times 4 will go into 4, 2 times 2. For 6, you would have 1 and 6. You'd also have 2 and 3. For 8, 1 times 8, but you'd also have 2 times 4. All right, so anytime a number has more than two factors, you know it's a composite number. We had also stated that the number 1 doesn't belong to prime or composite. It's not prime or composite. All right, so once we finished talking about prime and composite numbers, we went into prime factorization of a number, and we went over two methods. We talked about the factor tree method, and we talked about the repeated division method. So let's do a quick review on that. So we're looking at prime factorization. And the two methods we talked about. So let's do the factor tree method first. And let's say we're doing the number, let's just do the number 18. All right, so factor tree method, we're going to split the number 18 into two factors. So again, any two factors, so like 2 and 9 you can use. You can also use 3 and 6. Doesn't matter, any two that you choose. I'm just going to go ahead and use 2 and 9. All right, so 2 is already prime. We can't factor that any further. The 9 we can. We can factor that to 3 and 3. All right, so once you've reached prime numbers, you can't factor them any further, and these are our prime factors. So 18 is equal to 2 times 3 times 3. So that was the factor tree method. The other method is called the repeated division method, and I'm just going to do that on this side. All right, so repeated division method, we start with our number 18 and we set it up like this. And on the left-hand side, we are going to choose prime numbers, the prime factors that go into 18 on the left-hand side. So I can just start with 2. So 18 divided by 2, that gives me 9. And then 9 divided by 3, that'll give me 3. And then 3 divided by 3 to give me 1. And then we're completed. And then it's the ones on the left-hand side, which are the prime factors for 18. So again, 18 is equal to 2 times 3 times 3. All right, so that was the two methods that we used for prime factorization. So factor tree and repeated division. All right, once we completed our prime factorization, now we are able to find the greatest common factor. And that was our next lesson, which was greatest common factor. And it is abbreviated as GCF. All right, so we're looking for a factor that is common between two numbers, but it has to be the greatest factor that's common between two numbers. So for example, if we were looking at, let's do 24 and 60. All right, so let's say these were the two numbers, and we need to find the greatest common factor between the two numbers. So you can use whichever method you choose. I'll just use factor tree method here, and we're just going to get our prime factorization of each number. So for 24, I'll just use 2 and 12, and then 12 can be further factored, 2 and 6, and then the 6 is further factored to 2 and 3. All right, and then I'm going to factor the number 60 as well. So I can use for 60, 2 times 30 gives me 60, and then for 30, I can use a 2 and 15, and then for 15, it would be 3 and 5. All right, so to get the greatest common factor between these two numbers, you're going to find the numbers that are common to both, the prime factors that are common to both. So we have a 2 and a 2, and we have a 2 and a 2, and we have a 3 and 3. And those are the only ones that are common. All right, so then we would multiply those out. So our greatest common factor is the 2 times 2 times 3. Which is 12. So the greatest common factor for 24 and 60 is 12. All right, and then the last lesson for this unit was on finding the lowest common multiple, and that is abbreviated as well. It's abbreviated as LCM. That is our lowest common multiple. All right, so you're finding a multiple between two numbers, but the lowest one that's common to both numbers. That is what lowest common multiple is. All right, so again, we can use prime factor method, or you can use repeated division method. So let's take a look at an example. Let's say we had three numbers. They were looking for 24, 30, 36, and we need to find the lowest common multiple. All right, so I'm going to do this one with repeated division method. So we have 24, 30, and 36. And we're going to set it up like this. So we're going to start by looking for a common factor for all three of those numbers, and it does have to be prime number. So let's just use 2. So 24 divided by 2, that's 12. 30 divided by 2, that's 15. 36 divided by 2, that gives me 18. All right, another common factor that goes into 12, 15, and 18, we can use 3. 12 divided by 3 gives me 4. 15 divided by 3 gives me 5. 18 divided by 3 gives me 6. So we have 4, 5, and 6. And lastly here, when you have three numbers, but you can't get a common factor for all three numbers, you get it for two of them. So 4 and 6, we can use 2, and we just bring down the 5, and we end up with 2, 5, and 3. All right, and then to get your lowest common multiple, you just multiply the left hand and the bottom 3. All right, so our lowest common multiple here, 2 times 3 times 2. Those were the ones on the left. And then times 2 times 5 times 3. And those were the 3 on the bottom. Multiply those out. Use a calculator if you need to. And we got 360. All right, and that was it for this unit. So know your factors, know your multiples, know the difference between prime and composite, be able to determine the prime factorization of a number using the factor tree method or the repeated division method, and then be able to get your greatest common factor and your lowest common multiple.